It's time to review for our Unit 9 test. The first ones are going to be graphing, which you can always use a calculator for, but we're also going to list the domain, range, y-intercept, and the asymptote. And so the domain, range, y-intercept, and the asymptote. And so on this one, we're going up 1. That's the asymptote, y equals 1. Shifting left 2, 1, 2, there's my little reference point. We're going to have a stretch of 3, and so that's our starting point. We're going to be 3 away from the asymptote. 1, 2, 3, there's our starting point, and our rate is doubling. So every time we move to the right, we're going to double how far we are from the asymptote. This is 3 away, the next one's going to be 6 away, 3, 4, 5, 6. Next one's going to be 12 away, so 6, 7, 8, 9, 10, 11, 12. There's our y-intercept, 0, 13. Our domain, I'll go ahead and draw this first. If we'll go the other direction, it's cutting in half, so half of 3 is 1.5, 0.75, and it's going to keep getting closer and closer to the asymptote without touching it. Domain is always all real numbers. The range can be written one of two ways. Either the low point of 1 with parentheses because it's not touching all the way to infinity, or y is greater than 1. Either one will work. Number 2, the domain, the range, the y-intercept, and the asymptote. And so for this one, we're going up 1 again. And so there's the asymptote, y equals 1. We're going left 1, there's the reference point. Our starting point is 1/4, so just right above. And then our rate on this one is times 4. So 4 times a fourth is 1. So we're going, this was a fourth away, this is 1 away. There's our y-intercept, 0, 2. This is 1 away, the next one's going to be 4 away, because 1 times 4 is 4. 2, 3, 4. This one's 4, next one's going to be 16 away. And so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. And there's the graph. But again, if you struggle with this, you can always put it in the calculator. Domain and range on this one is going to be the exact same as the previous. Number 3, we're going up 2. So there's the asymptote, y equals 2. We're going left 2, 1, 2, there's the reference point. We're starting at 4, so 1, 2, 3, 4, and then this one, our rate is a half, which is a decay, so we're going to cut in half every time. This is 4, next one's 2, next one's 1, there's the y-intercept, 0, 3. The other way would be true as well. This is doubling as we go to the left, so there's 4, and then 5, 6, 7, 8, and it's going to keep doubling. So our domain, again, is always all real numbers. Our range can be written one of two ways. Either the bottom on this one is 2 all the way up to infinity, or y is greater than 2. Either way will work. Number 4, transformations. This 2 in the front is a vertical stretch by 2. X plus 4 goes left 4. This 2 doesn't do anything. That's just our rate. It's part of the parent function. And then minus 1 goes down 1. Number 5, we've got the negative in front, and so it's going to reflect it across the x-axis. 1/3 is going to be vertical compress. X minus 2 is going to go right 2. And plus 7 is going to go up 7. For these, it's probably going to be multiple choice on your test. So you can always plug it in your calculator and see which one's correct. But the asymptote goes down 1. It says listed transformation, so down 1. And so that's going to have a minus 1 at the end. And then we're going to find the point that's 1 away from the asymptote. So this point right here is 1 away from the asymptote. It's been shifted left 1. And then from there, it's 1 away, 2 away, 4 away, 8 away. And so this one's doubling every time. So my rate is 2 raised to the x plus 1. Same thing on this one, it's been shifted down 1. And the point 1 away has been shifted left 2. And then 1 away, 2 away, 4 away. So again, it's a rate of 2, x plus 2, and then minus 1. Starting at number 8 with solving, we have to get the same base on either side. For this one, you could either use 9 or 3, because 9 does go to 81. Anytime you have a fraction, it means you're going to have a negative exponent. So this is 9 to the negative first. I'm going to use 9 because it's less work. Over here, 9 to the negative second, because 9 squared is 81, the negative flips it. And so we get negative 2x equals negative 2x plus 4. Negative 2x on both sides, they cancel out, so we get 0 equals 4, which is not a true statement, so it's no solution. Number 9, we're going to use 6. 36 is the same thing as 6 squared. And if you don't know how many 6s it takes to get 216, we can just trial and error. Maybe you're like, oh, well, 6 to the 4th. Oh, that's too big. 6 cubed, there it is right there. So 6 cubed is 216. So negative 3p plus 3. 6 cubed, negative 2p. And distribute the exponents. We don't need the bases anymore. So negative 6p plus 6 equals negative 6p. Again, they cross out, we get 6 equals 0, not a true statement, no solution. Number 10, we could use 8, or we could use 2. We couldn't use 4 on this one because 4 doesn't go to 8, but we'll use 8, it's less work. So 8 to the negative n is good. Over here, 8 squared, negative n equals 2, n equals negative 2. On this one, you could use 4 or 2. 4 is going to be easier since that's already on the right side. 4 to the third is 64, and it's a negative because of its fraction. And so we get negative 9r minus 6 equals 3r. We'll add the 9r over to get 12r, and then we'll divide by 12, and r equals negative 1/2. On number 12, 5 is going to be our base, and so 5 cubed is 125, and 5 to the 4th is 625, and so 3m equals 4. We'll divide by 3, m equals 4/3. You use 8 or 4, either one. I'll use 8, 8 to the negative first. And then over here we have 8 squared, so negative 2m equals 2. M, we'll divide by negative 2, equals negative 1. All right, moving on to the next page. These will be the equation A equals P, 1 plus or minus R over N raised to the NT. But on number 14 and 15, they're very similar, and even 16 as well. We got to be careful on these. It says the town has a population of 5,000. That's our starting point. This one doubles. It doesn't give us a percentage or anything like that, and so we're not going to use the 1 plus. We're just going to put in this rate. That's our rate. So 2 is going to go in the parentheses, and it doubles every 7 years, so it doesn't double every year. And what will the population be 14 years from now? If I just put a 14 over here, that would mean it doubles 14 times, but that's not true to this question because it only doubles every 7 years. So we're going to divide the 14 by 7, or you could put in a 2, because if it doubles every 7 years, it'll double twice at 14. Either one's going to get the same thing. So we can put in our calculator, and so 5,000 2 raised to the 14 over 7, or 2, gets me 20,000. On this one, the city triples in size, so 3 is going to be my rate every 85 years. So it doesn't triple every year. Every 85 years, it starts at 50,000, and we're raising it. We want to know 170 years, so 170 divided by how often it triples. And so again, we'll put it in the calculator, and we get 450,000. And then the next one, number 16, very similar. We've got 50,000 bacteria. Number of bacteria doubles, and so we're going to have a 2 in parentheses every 4 minutes. So it doesn't double every minute, every 4 minutes, and we want to know 18 minutes from now. So we're going to take the 18, divide by how often it actually doubles, and I'm going to put it in the calculator, 50,000 times 2 raised to the 18 over 4, and that gets our answer 113137, and I'll round up to 1. Oh, and this is people up here. And this is bacteria. And so this one loses market value. That means we're going to be subtracting 5% per day. And so this is constant on units right here. It originally was worth 11,960. We're going to be subtracting 5% per day, which subtracting 5% means the same thing as keeping 95%, because a full percent is 100. So you can put in either one of these into the parentheses, and we'll raise it to the 10th power. And so 11,960, 1 minus 0.05 raised to the 10th power means that the corn is worth $7,160.89 after 10 days. Moving on, number 18.